Well, when you're going to write a covalent bond, the first thing you're going to do is write the formula, okay? So here is the very first example I'm going to show you. It's going to be carbon and iodine. So that would be our formula. That's step 1. And then it tells us to write the electron dot diagram for each element. Okay, so let's look at carbon. We know carbon's in group 4, so it has 4 valence electrons. So we draw carbon with 4 dots around it like that, okay? Next, let's look at iodine. So we draw the symbol for iodine like that. And we see, okay, iodine's in group 17. So there's 7 valence electrons. So I draw 7 dots around iodine, okay? And now my next step, that's the step 2. Step 3 is I need to find, basically here's what I want to find. The number of valence electrons that has to be combined in the whole atom, okay? And the way you do that is you multiply the number of each atom by the element by their valence electrons. So let's look at carbon over here. Here's carbon. And how many carbons do I have in this molecule? Well, anytime you see one of these little numbers down here, those numbers stand for subscripts. And subscripts will tell us the number of atoms of that particular element, okay? Carbon doesn't have a little number by it. So we just pretend that there's an invisible 1. Okay, that tells us there's 1 carbon atom. So over here I'm going to write carbon equals, put 1 in parentheses. That's how many carbon atoms I have, okay? Now let's look at the valence electrons in carbon. How many valence electrons are in carbon? Well, there's 4. So if I have 1 atom of carbon and each atom of carbon has 4 valence electrons, then how many valence electrons am I dealing with from carbon? I'm dealing with 4, because 1 times 4 is 4. Now iodine, how many atoms of iodine do we have? We have 4 atoms of iodine, right? Because its subscript is 4. So I put that here. 4 times, now how many dots or how many valence electrons does 1 atom of iodine have? Well, it has 7. So 4 times 7 is 28. So if carbon has 4 valence electrons and iodine has 28 valence electrons, we're looking for a total of 32 valence electrons to be shown in our structure, okay? So that's step 3. Pay attention. It's chemistry. Chemistry is life. Step 4 is to draw the Lewis structures fitting together. Now here's the main rule. Carbon, anytime you have a carbon, it's always going to be the central element and you'll kind of build around it. And if there's no carbon, then you would take the least electronegative atom and that would be the one that's in the center. By the way, BT dubs, hydrogen is never central. So since we have carbon, it'll be the central atom. So I draw carbon here and I draw my 4 dots on carbon, okay? Now let's think. How many more dots would carbon need to get 8? It would need 4 more dots, right? Well, iodine each has 1 dot that they need extra, right? And since there's 4 iodines, each of them would want 4 dots. So here are 7 electrons. Guess what happens between this right here? That's what's called a bond. They're both sharing the electron. Does iodine have 8? Yes, it does. Does carbon have 8? No, it only has 5 now, so it wants to get 8. So I'm going to put another iodine right here with its 7 electrons, and it will share that atom with carbon. So now carbon has 1, 2, 3, 4, 5, 6, so it needs 8, so I'll put another iodine atom here where they're sharing electrons, right? And then my last iodine atom is going to fit in. I knew there were 4 I's because it tells me that right here. And then I figured out where the I's went because I kind of just like fit them in like puzzle pieces. Okay. Now the next step we're going to do is replace the shared dots with bond lines. Each hydrogen, if you have a hydrogen, will have 1 bond, but every other element should have a total of 8 valence electrons around it. So I'm going to go ahead and draw my elements. Here's iodine, 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 carbon. And I draw a line everywhere there was a shared pair of electrons, okay? This line stands for a bond, and a bond always has 2 electrons. Now I also want all the other electrons there, like iodine has electrons, but I'm drawing them in different colors because we call these lone pairs. Each of these is considered one lone pair. So iodine has 3 lone pairs, meaning that there's a pair of electrons, but they're not, they're alone, meaning they're not actually part of a bond. Okay, and this iodine also has 3 lone pairs, this iodine has 3 lone pairs, and so on and so forth. The last thing you do is count all your electrons to be sure the number of valence electrons in your structure will equal the number from step 3. Okay, so step 3 said we had 32 electrons. So do we have 32 electrons in our picture? Well, let's go ahead and count them. Okay, I have 1, 2, 3, 4, 5, 6. Remember, this line stands for 2. So that's 7, 8, right? 9, 10, 11, 12, 13, 14, 15, 16. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So 32 valence electrons means that I set my atom up right. That's kind of a way to check yourself, okay? So let's do another one. Second thing we do is write the dot structures. Phosphorus is going to be in group 15, so we draw 5 dots. Chlorine is in group 7, so we draw 7 dots. Okay? Now we have, remember there's an imaginary 1 there, okay? So phosphorus, we have 1 atom of phosphorus times, how many valence electrons are in phosphorus? 5. So we have a total of 5 valence electrons from phosphorus. We have 3 atoms of chlorine times 7 valence electrons in chlorine. So that gives us a total of 21 valence electrons from chlorine. So we should have a total of 26 electrons when we're done. Okay, that'll help us check ourselves. Okay, now let's go ahead and try and pair them all together. Well, which atom is going to be going in the middle? So I draw phosphorus in the middle, and it's got its 5 electrons. So since I kind of have these blank spots on the top, the bottom, and the left side of phosphorus, that's probably where the chlorine's going to connect, okay? So here's my chlorine, and it has 7 valence electrons, so I draw 3 lone pairs, and then this one's going to connect with phosphorus there. And guess where the other 2 chlorines are going to go? One of them is going to connect on the bottom, and then the other one's going to connect on the side, right? So there's 3 bonds there. So now I'm going to go ahead and draw them with the bonds. And you want to make sure that every element has 8 electrons. Notice phosphorus has 2 here, 2 in this bond, 2 in this bond, and 2 in this bond. So phosphorus has its 8 because it's sharing them. Okay, now let's check if we count all our electrons. Let's count all the lone pairs first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we count our bonds, 19, 20, 21, 22, 23, 24. Wait. Oh, I forgot these 2 lone pairs on the side. 26. So that means I've done my molecule correctly, okay? Now, something else I want to show you is that you can have some bonds that are more than one bond. You can form multiple bonds, and multiple bonds are double bonds, which look like this, and that's when there's 4 electrons being shared, and then you can have a triple bond, which looks like this, and that's when there's 6 electrons being shared. Okay, so let me show you some examples of double and triple bonds. These bonds are usually formed between carbon, whenever there's a carbon, nitrogen, oxygen, phosphorus, and sulfur. Those are the only elements that will form double and triple bonds. So we always say CNOPS forms multiple bonds. Okay, so let's see how that looks in action. Okay, here's, we have example 3 and example 5. I'm not sure what happened to example 4 or if it's written on your paper at all, but I'm going to jump down and do carbon dioxide as my next example. Okay, so it doesn't matter where you put that in your notes, just one of the boxes. Let's do carbon dioxide. So first thing we do is we write our dot structures. Carbon has 4 valence electrons. Oxygen has 6 valence electrons. Okay, and now we do our numbers. Are you paying attention right now? I'm watching you. Just kidding, guys. I'm not really watching you. But And then we're going to go ahead and draw the two oxygens. There's one oxygen here, right? And it has 6 valence electrons. One of them will be shared with carbon there. But then there's kind of this lone electron right here on top. See that? If we draw the other oxygen here with its electrons like this, that forms a bond. But notice there's kind of a lone pair down here. Well, what happens is that these two are actually going to form a bond as well, and these two are actually going to form a bond as well. So what it actually ends up looking like is here's carbon. It has its 2 electrons here, and oxygen has its 2 electrons moved over here. So there's one bond there and one bond there. That's a double bond, and one bond here and one bond here. That's a double bond. Okay, and the best way to realize whether or not there's going to be a bond is by seeing, is there any like lone electron by itself? See how carbon had a lone electron and oxygen had a lone electron? That's why I decided to bond them together. Okay, so how do we draw that out? Well, I draw my carbon, right, and my 2 oxygens, and I have 2 bonds, so I'm going to draw 2 lines demonstrating the bonds, right? And then, okay, now you have to think, does carbon have any dots extra around it? Well, let's see. There's 2 electrons in this first bond, 2 electrons in the second bond, so that's 4 electrons that carbon has, and then it has 2 electrons in the other bond and 2 electrons in this other bond. So it has a total of 8 electrons. So does carbon want any other dots around it? No, it doesn't, because it has a full 8. Now, each oxygen right now only has 4 electrons from those 2 bonds. So it needs another 4, and so it has a lone pair out here and a lone pair out here. Okay, so let's double check to make sure we did this right. There should be 16 valence electrons. So let's count the lone pairs first. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we did it right. Electrons don't want to be near each other. They want to repel. So when we have electrons on the outside of an atom, they don't like to be near each other. They naturally are going to push away from each other to get more distance. So that creates a different shape for atoms with different numbers of electrons. So let's take a look at an atom that has, or a molecule, I'm sorry, that has 2 atoms. So if I have a molecule with 2 atoms, so here's an atom right here, and then here's another atom, and I've drawn that there's a bond between them. It could be a single bond, a double bond, a triple bond, it doesn't matter. But if there's 2 atoms, they are going to take the shape of a line. If you have 3 atoms, we call that 2 atoms around a central atom. And they form, again, a linear shape. And so this linear shape, the only 3-atom molecule that doesn't form a linear shape is water. Water forms a shape that we call bent, meaning it kind of looks like it should be linear because there's 3 atoms, right? There's 2 H's and then there's 1 oxygen. So the oxygen's in the middle right here, and the H's are on the side. And the reason why they're bent is because oxygen actually has 2 lone pairs on either of its ends. 2 of the electrons are found in this bond here. 2 of the electrons are found in this bond here, and then it has the other 4 electrons are lone pairs. These lone pairs right here actually repel the hydrogen, and so it pushes the hydrogen downward to form a bent shape. So if you have 4 atoms, then you're going to put 3 of the atoms around a central atom. So here's your central atom. Okay. This Y shape is completely flat, and the angles between each bond is 120 degrees. This shape we call trigonal planar. Trigonal stands for 3 sides, and planar stands for it being flat on the same plane that you're working on. So if you have 5 atoms, again, you're going to put 1 in the center, always put 1 in the center, and then you're going to have 4 atoms around the center atom. And we draw this a little bit funky because it does not sit flat on the page. This shape is called a tetrahedral shape. We have the central atom in the middle. We have 1 atom going directly up from the center atom, like so. We have another atom going directly, again, to the bottom right of the atom. Then you're going to have one that sticks out in front, and so we draw it with this like triangle, and that shows that this particular leg is actually coming towards us. It's coming out of the page at us. And then we have one atom that's actually going into the page away from us. We draw it with a dotted line. So essentially, think of this atom as this being in the center, and it's actually above, like if this is the flat surface right here, this is the table, it's standing upward, okay? And then these are the three legs holding up the center atom, and then this atom is going straight up to the sky. Here's an example of a tetrahedral shape. You can see the center atom is kind of raised above the ground, and then the other three atoms are supporting it, and the fourth atom is standing kind of up straight. This is the bond angle. It's 109.5 degrees between each atom. And here is a overview of the shapes. The linear is for 2 to 3 atoms, forms 180 degrees. Bent is only for water. Trigonal planar is 4 atoms at 120 degrees, and tetrahedral is 5 atoms at 109.5 degrees. And that is it for this video, guys. Exciting stuff. Yeah.